Okay, so it took me a while to get this video started, but here we go. I'm just going to do a quick breakdown of how to answer every single one of these questions. What section from the book you might want to refer to. Keep in mind, these are just, sample questions. Doesn't mean that that this is exactly what the test is going to look like. All right, for every one of these questions, 5 others can be, made that are similar, or slightly, modified in some shape, way, or form. All right, so let's get started. So for question 1, it simply says find the value of x if, and they give you these 4 conditions. Q is between P and R. PQ is equal to 5x minus 10. QR equals 3 times x plus 4, and PQ is congruent to QR. So again, here the big one is that PQ is congruent to QR. So now where do you might you want to go look in the book? Section 1.2, postulate 1, 2. The I believe is your segment addition postulate. I have my book here. Let's see. Come on. Yeah, segment addition postulate. Example 3 is also a good place to look, and then your key idea of congruent segments. As again, you need to know what the symbols mean and what's going on here. Now, if the question, if it wasn't giving you that the 2 segments are congruent, it could be possible that you need to add the segments and set them equal to something else. The good thing to do is sketch what the figure might look like. Don't worry about how good it looks necessarily. Just make a segment. We're given 3 points. Q is in between, so Q, P, and R. And then PQ is 5x minus 10, so then from here to there, 5x minus 10. And then QR, 3 times x plus 4. Oh, the image quality is terrible. Oh well. Now we also know the segments are congruent, so in our figure we might want to label with the congruent symbols. Okay, so since they're congruent, remember congruent is essentially just another word for the 2 things being equal, so we can take our expressions, set them equal to each other, and then you'll have an equation that you can solve. Remember, you got to show your work here in order to get full credit. I'm just gonna break down how to set them up and what sections you want to refer to, what chapter, and that's about it. So that's question 1. Question 2. Now here we're talking about angles. This is using your angle addition postulate found in section 1.5. Example 4 is a decent reference, and one of the differences here is that you have expressions, and I don't know if the example is going to have just numbers or expressions like we see in this question. Remember, you want to also go to the modules in Canvas. All the notes should be uploaded for everything that we covered. So that would be a good place to look in section 1.5. Look for anything involving angle addition. You'll have extra examples, some completely worked out and some that just have the solution. Good practice problems. So moving on. So a good way to address this one is, on your scratch paper, just make a quick sketch of the graph of the figure here and label it. Alright, remember, just follow the letters in the order they are listed to determine which angle we're talking about. So X, Y, Z, X, Y, Z. Since that's the whole thing, it's not really going to be convenient to put the angle measure in here. You don't want to confuse it with this one or this one. So if we're talking about the whole angle, I usually put that on the outside, like that. So then this angle is referring to X, Y, Z. X, Y, W, so X, Y, W is this one right here. So let's put 9x plus 6 there. W, Y, Z, the little one, so 40 minus x. So they're asking you to find the measure of W, Y, Z, so that's the little one here. So that means first we need to find the value of x, and then plug it in here to figure out what the actual measure is. Again, it's just angle addition postulate. Since the big angle is equal to 110, well then, if we put these two together, combine them using addition, segment addition, or angle addition postulate. Now we have an equation that we can simplify and solve. So that again, you got to find x and then plug it back in. Another thing to keep in mind, even though this is multiple choice, you're not guaranteed to have multiple choice appear much in the EOC. I don't know how many multiple choice questions there are going to be, but it's going to be a mixed bag of the types of questions. This one, I imagine, is going to have the text box, and then you type in whatever the correct value is. So again, gotta sort this out. For this one, our solution is 32. So I guess I can give you the solutions, but again, I'm not going to show you the work. You got to show the work or you won't get full credit here. Jumping back to question 1, x equals 11. Alright. This one, question 3. Now, if you get this one for multiple choice, it's much easier. A couple of things that we need to know here. The definition of the word. It says the ratio of the measures of an angle to the measure of its complement is 2 to 3. What are the two angle measures? So, gotta know what complement means. If you don't know what complement means, then that can impact your, whether you get the answer right or wrong. Now, if it's multiple choice, again, that gives you an advantage. Since we know the ratio is 2 to 3, we can use, you can use that to help us out. For example, by taking 30 and 45, we compare 30 to 45. And if we simplify those, well, we know that 30 to 45 reduces to 2 to 3. Okay, so you might say, oh, that's got to be my answer. But again, let's come back to the word complement. Complement means, let's see, you can find that in section 1.6 and 1.5. Those are the two sections you might want to refer to for number 3 here. Complement is when two angles add up to 90 degrees. So we say, okay, well, it matches the ratio, but if we add 30 and 45, that's 75. So that one cannot work. Alright, so repeating this, we find that I believe C and D are also 2/3. Let me double check here. C and D are also 2/3, but again, complements, meaning they add up to 90. No way it could be D, so the correct answer would be C. Now again, it's a multiple choice version of the question, so that makes it a lot easier. Then if it's not, which is again probably the way I would expect a question like this to come up, they give you little text boxes to type in the two angle measures. So then what do? Well, let's keep in mind that anytime when it comes to ratios, many times they are simplified. Again, 30, using the first example here, 30 over 45, they canceled out, they simplified to 2 to 3. So why is that? Well, remember, if we take 30 and 45, right, 30 and 45 are both divisible by 15. Right, so that's how it reduces. 30 is 2 times 15. 45 is 3 times 15. So they have that common factor that cancels out, and that's how we get 2/3. That's supposed to be 2/3. Again, the image quality is what it is because this camera here is old. Let's see if we can adjust that real quick. No. That's as good as it's going to get, I suppose. Alright, anyway. So, we can use that, like understanding how we get ratios is something that can help us answer a question like this. Because what we know so far is that, well, they're complements, so that means they add up to 90. So we can use it, make a quick sketch of, a 90-degree angle to say, well, I don't know what these two measurements are, but I have these two angles. Now again, we need these to be two measures that are complementary, so all we know is that we have 2/3 and they have some common factor x that cancels out. Right? They have some common factor x that's going to cancel out, reducing the ratio of the two angles to 2/3. So we can set up our problem here by saying, well, this can be 2x, this can be 3x. And since they're complementary, we know that 2x plus 3x is equal to 90. Again, most of the work is already done there, so we need you to finish it up. Because from here, you can sort this out, find the value of x, plug it back in, and then you can get your angle measures here and here. Alright, so that's it for that one. Over here, number 4, angle QUT. So something of note here is that angle QUT, again, just like we did up here at the top, and the names of the angles tell you, what points to follow. So QUT is asking us to find QUT, this angle that I've labeled in blue. I don't know if you can see it, this one right here. So you might say, well, that's kind of weird because there's no expression there, so how am I supposed to go about that? So again, here you want to look at section 1.5 for your angle addition postulate, but then you also want to check 1.6 where they talk about linear pairs. Alright, because remember, linear pair, that kind of joins up with adjacent angles in that linear pairs form a straight line. So if two angles together form a straight line, or if you just have a straight line by itself, it's understood that that's a measure of 180 degrees, which would make these two angles, or these two angles, supplementary, right? Because you have a straight line right here from or straight angle, QUS, so that's QUT and TUS together. You also have QUT and QUR together, forming a straight angle here together. So how do we go about this? Well, since we do have these two expressions here, again, section 1.6, definition of vertical angles, and then I believe later on in section 2.6, you have the vertical angle congruence theorem, which tells us that vertical angles are always congruent. So this one puts those two lessons together. So knowing that these are congruent, well, again, congruence means they are the same. So we can set these two equal to each other, find the value of x. Once you find the value of x, plug it into either one of these two, and then subtract it from 180, and there you go, QUT. For this one, QUT should be 42. In the event that in a question like this you get some number that's, let's say you had gotten 138, you did everything right, but you got 138, keep in mind some of these figures are not going to be drawn to scale. So if it doesn't look a certain way, again, read the questions carefully, because if it says that it's not to scale, don't put too much on the picture. And moving on to question 5. Question 5 takes us to chapter 3. So a couple sections you want to check there, 3.1 and 3.2. 3.1 towards the end of the lesson shows you the different kinds of angles created when you have two lines cut by a transversal. Section 3.2 gets a little more specific in that it tells you which angles, what the angle relationships are between those angle pairs. So the 4 types of angle pairs are corresponding, alternate interior angles, alternate exterior angles, and consecutive interior angles. Consecutive interior angles are sometimes referred to as same-side interior angles, so it's helpful to keep both of those in mind, because I don't know which one is going to show up on the test. Alright, so right here, so if you go through those different types of angle measures, you might say, it's like, well, 1 and 2 don't fit any of them. If we, a quick review here, let's add some extra numbers. This is angle 1, 2, so we'll put 3 here, 4 there, 5, 6, 7, and 8. Alright, so 1, 3, 4, 5, 6, that's a 6, I know. 2, 7, and 8. So now remember, for corresponding angles, that's when they are in the same position of their respective groups. When you have two lines cut by a transversal, well, you get two groups of 4. See, 1, 3, 4, and 5, that's one group. 6, 2, 7, and 8, that's a second group. So the angles are in the same spot of their respective groups. That's what makes them correspond. So angle 1 and angle 6 are both on the top left of their group. 3 and 2 are in the top left of their group. 4 and 7, 5 and 8. So those would be your corresponding pairs. Now, corresponding angles, those are congruent. Alternate interior, those are congruent. Alternate exterior, those are also congruent. And then finally, the consecutive interior, those are the only ones that are not congruent, with the exception of a special case. Those are supplementary. So we've just established, okay, well 1 and 2, those aren't corresponding, so then they're not congruent. So we move on to alternate interior. Looking over, that one doesn't fit either because angle 1 is on the outside, is on the exterior, angle 2 is on the interior. Alternate interior requires both of them to be in between the two lines. So 4 and 2, 5 and 6, those would be alternate interior. Then we go on to alternate exterior. That doesn't work either because 1 is exterior but 2 is interior. Again, doesn't make any sense. So 1 and 8 would be alternate interior, so we know those are congruent. 3 and 7 are alternate exterior, so those would be congruent. I think I said interior, I meant exterior. So how does that put 1 and 2 together? Finally, having gone over the difference between interior and exterior, consecutive interior doesn't make any sense either because 1 is on the outside, it's exterior. So what gives? How are we supposed to do anything with this? Well, keep in mind, just because these two, angle 1 and 2, do not have a direct relationship to one another, doesn't mean we cannot use transitive property to help us out here. We can say, well, 1 and 5 are vertical angles, so we know that 1 must be equal to 5. Since 5 is, so let's put that down. Right, we know that since they're vertical angles, the measure of angle 1 must equal the measure of angle 5. Vertical angles, congruence theorem. And then we notice, oh well, 5 and 2 are consecutive interior. Well, then that tells us that the measure of angle 5 plus the measure of angle 2 must be 180. They must be supplementary. And then now we can use our either substitution or transitive property, whichever one you want to classify it as. Substitution is really a better fit in this case, but anyway. So angle 1 can go in place of angle 5. Again, since they are equal, they can be replaced. So now we've determined, okay, while 1 and 2 do not directly have that same side interior, consecutive interior relationship, we're able to link it through the relationship between 1 and 5. So angle 1 plus angle 2 is equal to 180. There we go. We have an equation that we can then use to sort this out and find the measure of angle 1. So find the value of x and then substitute it here, and you should get D. Alright, question 6 pretty much does the same thing that we just talked about over here, but this one's a lot nicer because we can clearly see, oh look at that, they are same side interior, sorry, consecutive interior. So set them equal, let's not set them equal to each other, add them up, set them equal to 180, and go from there. Now again, taking this time to remind you that just because this example here is using the consecutive interior doesn't mean they couldn't have put the 7x plus 5 over here. It's changing the situation from consecutive interior to alternate interior, and then you have to set them equal to equal. Okay, gonna try to keep my hand out of there. But yeah, they could easily take this angle and maybe put it over here instead, making the relationship between them alternate interior instead of consecutive interior, and now the way you set it up changes. Instead of adding them and setting them equal to 180, you would have to set them equal to one another. But for the problem here, number 6, we do the same thing we did question 5. Add them up, set them equal to 180, solve, and this time you're only looking for x. So, goodness gracious, this camera. So D. Option D here. Let's see. Alright. Moving on. Question 7. Question 7 takes us to chapter 5, specifically sections 5.3, 5.5, and 5.6, where you discuss the different congruence theorems for angles. You have 4 of them listed here: angle, side angle, hypotenuse leg, side angle, side, 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 side. I'm just going to add it here for the sake of having it: angle, angle, side. This is the type of question that could also be multi-select, depending on what information is given. Okay, so now for this one, look at what you have. Since you have the 90-degree angle, I would start by investigating hypotenuse leg, and that will actually end up getting you the right answer in this case. Because you might say, well, I only have one 90-degree angle, so what gives? keep in mind what we previously discussed. We have vertical angles which are congruent, so that means the 90-degree angle over here too. Alright, so since both are right triangles, well then hypotenuse leg is definitely in the running. If it's now, could it be something else? Certainly. But if you're dealing with right triangles, that's the one to investigate first. So looking at, as I said, the first one we want to look at is hypotenuse leg, because we have those two right angles here. So now would it work? Again, in this instance, yes, that's going to be the case, because since this is the 90-degree angle, well, remember the hypotenuse is always across from the 90-degree angle. And one way that I like to think about it is kind of the right angle box here kind of looks like an arrow. Where is it pointing at? Always pointing towards the hypotenuse. The hypotenuse in both instances have one tick mark, therefore they are congruent. That means the other two sides are the legs. Here the legs are congruent since they have two tick marks, so you have congruent hypotenuses, congruent legs, so checks out. And again, this takes us back to sections 5.3, 5.5, and 5.6. It's important to look at different examples for how the other ones can apply. Side, side, side being the easiest one, because that just means all three sides are congruent. So if you can show in some way that all sides are congruent, you know, that's the way to go there. Alright, so yeah, you want to go and look at those again. Check the notes. There are some additional examples that you can use to review as well.